Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 2 paper from autumn 2023. This paper is worth 120 marks in total, and this is the fourth video of 6. It will focus on questions 14 to 17, which account for 22 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. 14a. The amount of electricity and gas used in a home is measured in units. In the first week of May, the Singh family used 56 units of electricity and 245 units of gas. The cost per unit of electricity is 32 pence. The total cost of the units of electricity and gas the Singh family used in the first week of May was £39.97. What is the cost of 1 unit of gas? Okay, so we have 56 units of electricity. Each of them costs 32 pence. So we're going to do 56 units times that 32 pence, which is 1,792 pence, which is £17.92. So it costs them £17.92 for those 56 units of electricity. Okay, they used 245 units of gas. But the next piece of information we get is the total cost for electricity and gas. So the total cost for electricity and gas was £39.97. So I'm going to take this, the cost of electricity, away from £39.97. So £17.92. So £39.97 subtract 17.92. So this tells me that the total cost for gas is £22.05. Now they did 245 units, so I'm going to divide £22.05 by 245, which is £0.09 or 9 pence. Doesn't matter which way around, but that's how much per unit of gas. So I'm just going to put 9 pence on the answer line. Part B. The Singh family are calculating their electricity bill for the 30 days of June. They used 210 units of electricity in June. The cost per unit of electricity is 32 pence. They pay a fixed charge of 28 pence per day, and VAT at 5% is added to the total of these costs. Calculate the total cost of the Singh family's electricity bill for June. Okay, so we've got 210 units of electricity at 32 pence. So let's start there. 210 times 32. So that would be £67.20 because that's 6,720 pence. Okay. They also pay 28 pence per day and there's 30 days in June. So we're going to do 30 times 28, which is £8.40. Okay. We're going to total that up now, guys, because this will be their total bill. So add the £67.20. So we have a total of 900. I've pressed something wrong there. Oh, I know. I didn't change it to pounds, did I? That is a more reasonable price. What was I thinking? Okay, £75.60. So that's the total cost, but they pay VAT of 5% on top. So we need to find 5% of that total and then add it on. So because this is a calculator paper, again, I'm going to work with a decimal multiplier. So 5% is 0.05. If you don't know how to get a decimal multiplier, if you just divide the percentage by 100, you're going to get a decimal there, guys, and that's your decimal multiplier. So I'm going to do £75.60 multiplied by 0.05, which is £3.78. So we need to add that to their total. So £75.60 plus the £3.78, which is the VAT. So we have a total cost of £79.38. So the total cost for electricity for the Singh family was £79.38. Question 15. Rhiannon cycled from home to a park. She cycled 15 miles along a straight road. The graph shows her journey. So this is the distance she is from home. So this is at home. This is the time taken. Part A. On her journey to the park, Rhiannon had a puncture. How long did Rhiannon stop to repair the puncture? Now, if she had a puncture, she stopped, then we're looking for any parts of the graph that are horizontal. So this is travelling, stopped, travelling and stopped. So on her journey to the park, she got a puncture. So we're dealing with this part here, okay? Because 15 miles along a straight road, that's when she got to the park. So we're going to read down from where this line starts to where this line ends. So it ends at 10 o'clock, but it starts here. So that would be 9:45. So each of these are worth 3. So 3, 6. So that's 9:36. So from 9:36 till 10 o'clock is 24 minutes. So it took her 24 minutes to repair that puncture. Part B. Rhiannon was, on average, travelling faster before she had a puncture than after she had a puncture. Without calculating any speeds, explain how you can tell this from the graph. Well, this section of the graph is before she had a puncture. And then this section of the graph when she's travelling is after the puncture. Now, the orange line at the start of the journey, so before the puncture, is steeper. And that's how we know she was travelling faster. So we can simply say, before the puncture, the line was steeper. Part C. Rhiannon left the park at 11:30 and cycled back along the same road to a friend's house that is 5 miles from her home. This journey took 45 minutes. Draw this journey on the graph. Okay, so we're going back to this graph here, guys. So she's travelling, here she's at the park. She's travelling from the park to her friend's house, but her friend's house is 5 miles from her home. So she's not going all the way home. She's only going to the point where she's 5 miles away. So that's important to note. It says that this journey took her 45 minutes. So from here, so from 11:30, 45 minutes would be at 12:15. She's only travelling to 5 miles away from her house. So this is where her friend's house is. So that we're going to join that line onto the graph there. I did it in pen, guys, so you could see it nice and clearly. Obviously, please do it in pencil in case you need to rub it out. Okay. Part 2. Calculate the average speed of Rhiannon's journey from the park to her friend's house. Give your answer in miles per hour. So we're calculating the average speed of this part of the journey. Okay. So speed is distance divided by time. So let's see what, if we're working out speed, we want distance and we want time. So let's have a look at this graph. So here, she was 15 miles away from home, but here she's 5 miles. So the distance was 10 miles. 15 subtract 5 is 10 miles. The time, well, they tell us the time. It took 45 minutes. But when we're calculating with speed, distance and time, we don't want our time in minutes, we want it in hours. So that is 45 out of 60. So that's 45 out of 60 minutes in an hour. If you put that into your calculator or you could work with that as well, but it will simplify it for you. So we're working with 3/4 of an hour. So speed is distance divided by time. So to work out her speed, we're doing our distance of 10 divided by our time of 3/4. So 10 divided by our time of 3/4, which is 13.3. Don't forget the recurring symbol because that 3 continues. Question 16. This is a map of a holiday park. So this is our holiday park and we've got some landmarks noted on there. Part A, measure and write down the bearing of the reception from the park entrance. So we're working with the reception and the park entrance. So the first thing I'm going to do is I'm going to draw a line between them because that helps me when I start to use my protractor. We are using a protractor because it tells us to measure. It doesn't tell us that the diagram's not drawn accurately. It tells us to measure. So we want the bearing of the reception from the park entrance. So we're starting at the park entrance. These north lines are really handy. If we didn't have those, we'd have to draw them because we measure bearings from north in a clockwise direction. Okay, so the bearing of the reception from the park entrance is this angle here. Okay, so you can either measure that whole angle, but bearing in mind I don't have a full protractor, I only have half of one. I'm going to measure this little angle in here and then use it to calculate that angle. Okay, so first thing I'm going to do is I'm going to measure this angle, and that's why I drew this line. Now my protractor's not the best for this. Yours will be better in school because they have 2 rows of numbers. You have an inside row and an outside. I don't. Anyway, so we're lining up this centre mark on your protractor with this point here. So we're lining it up, and then this line is getting lined up so that it's parallel and flush on my north line. And then I'm going to start here and I'm going to read that angle around to that line that I've drawn. Now for me, I'm going to have to count backwards because I'm starting at 180. So that's 10, 20, 30. So this is 30 degrees. I'm sure your protractors will be a little bit less weird than mine. So if this is 30 degrees, this whole angle around this point at the park entrance must equal 360. So 360 subtract 30 is 330 degrees, and that's our bearing. Now, point to note on bearings, guys, they have to be 3 figures. So if I was writing 30 as my bearing, I have to write 0, 30. But luckily, my answer is in 3 figures. Part B. Amir is camping at the holiday park. His tent is on a bearing of 0.025 degrees from the park entrance and 280 degrees from the park exit. So we want a 25 degree angle from the park entrance and a 280 degree angle from the park exit. And then once we plot those angles, we need to mark with a T the position of his tent. So it's 25 degrees from here and 280 degrees from here. So the first thing I'm going to do is I'm going to plot my 25 degrees from the park entrance. So remembering this centre part of your protractor goes on the point that you're measuring your bearing from. The line goes on your north line, nice and flush. I'm starting at 0 here and I want to go to 25. So 25 is there. So I'm going to make a really clear mark. Okay. And then I'm just going to, from my park entrance, through that line, that mark I've just made, I'm just going to draw a line. Again, I'm using pen so you can see it nice and clearly. In your exams, use a pencil, guys, please. Now, we need 280 degrees from the park exit. Now, again, I don't have, if you have a protractor that goes all the way round, fantastic, lifesaver. You can just stick that on and you can go all the way round to 280. Mine doesn't. But what I do know is that straight down, that would be 180 degrees. So if I want to go 280, I only need to go another 100 from that line. So I'm going to put my middle point of my protractor on the point that I'm measuring from. This line is going to go flush with that line I've just drawn to identify my 180 degrees, and I want to go round another 100. So 100 is here, so I'm going to make a mark there. Once I've done that, I'm going to join my park exit point and the point I made for 280 degrees. Now you'll see that they intersect. It's good that they intersect because that's exactly the point where Amia's tent is going to be. So we're going to label that T. Question 17. The universal set contains the numbers 4, 9, 12, 18, 23, 32, 50, 64 and 72. S is the set of square numbers. F is the set of factors of 36. Part A, show this information in the Venn diagram below. So we've got to complete this Venn diagram. So the first thing I'm going to do, this is the universal set, so the overall set. I'm going to figure out what are in these sets because we need to find out what's going to go in the square numbers circle, what's going to go in the factors circle, and what's going to go in the middle because it's in both the square numbers and the factors of 36. So I'm going to identify the square numbers from this list. Now if you're not comfortable with your square numbers, just go ahead and square root all of these. So square root of 4 is 2, so 4 is a square number because it gave me a whole number. Square root of 9 is 3. So 9 is a square number. Square root of 12 is not a whole number, so it's not a square number. Square root of 18, again, and keep going, but I know that the other square number up there is 64. We want factors of 36 now. So 1 and 36, 2 and 18, 3 times 12, 4 times 9, and then it would be 6 times 6. So is 4 in that list? Yes. Is 9 in that list? Yes. Is 12 in that list? Yes. 18? Yes. 23? No. 32? No, and the rest of them are too big. So these are my square numbers and these are my factors of 36 that are in that list. Now we're going to identify any they have in common. So we have 4 and 4, 9 and 9. So 4 and 9 go in the middle of our Venn diagram because they are square numbers but also factors of 36. Now in the square numbers circle in this section here, we're going to put 64 because that's the square number that's left. And then in this section of the factors of 36, we're going to put 12 and 18 because that's the numbers that are left. So we've got 4, 9, 12, 18 and 64. These numbers still need to go in the Venn diagram, but they go on the outside because they don't belong in the square numbers and they don't belong in the factors of 23. So, factors of 36, sorry. So 23, 32, 50 and 72. So that's your Venn diagram complete. Part B. A number is selected at random from the universal set. Find the probability that the number selected is a factor of 36 but not a square number. Okay, so if a number is selected at random from the universal set, it's selected at random from here. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So our probability is going to be out of 9. Alright, we want the probability that it's a factor of 36, so it's in this circle, but it's not a square number, so it can't be in the middle. So we've got 1, 2, so the probability is 2 over 9.